Right, another past exam question. So this is an Edexcel Core Mathematics C4 question from the year January 2008, and this was question number 5 on that paper. So a curve is described by the equation x cubed minus 4y squared rather, that is equal to 12xy, and in part A we need to find the coordinates of the 2 points on the curve where x equals minus 8. So let me copy down the equation. So we have x cubed, so x cubed minus 4y squared, and that is equal to 12xy, and we have this value of x which is minus 8. So to find the coordinates, we not only need the x but we need the corresponding y. So let me simply replace the x by minus 8. So if I replace, and make it as neat as possible, x by minus 8 in this very equation, we're therefore going to get minus 8, and it's minus 8 cubed, minus 4 into y squared, so y's are the unknowns, that is equal to 12 into x replaced by minus 8 multiplied by y. Now minus 8 cubed, so 8 cubed is 8 times 8 times 8, which is 512. Minus cubed is a minus, so it's minus 512 minus the 4y squared. This is what we have on the left. 12 times 8 is 96, but don't forget the minus, so minus 96y. And let me rearrange this to form a quadratic. So if I take these two terms on the left and move them to the right, this is going to be the form of our quadratic. We're going to get 4y squared minus 96y plus 512, and that is equal to 0. So this is the resulting quadratic in terms of y. I think we can reduce this quadratic if we divide. So if we divide by 4, okay, we're therefore going to get y squared minus, and 96 over 4 is 24, so we got 24y plus 512 over 4, that is 128, so 128, and that is equal to 0. Now looking at this quadratic, you can solve it by using the formula, the quadratic formula, or you can factorize. So it's possible to factorize here. So if you were to factorize, I imagine the factors would be y minus 16 and y minus 8. So these should be the factors. And judging by this factorized expression, you've got two answers for y. So either the first term, y minus 16, is equal to 0. And when you rearrange this, the y value is going to be plus 16. Moving the minus 16 to the right will give you plus 16 for one of the answers for y. Or the second term, so y minus 8 is equal to 0. So that implies if I move the minus 8 to the right, y is equal to plus 8. So these are the corresponding y values. So let's summarize. So they did want the coordinates of the 2 points where x equals minus 8. So to summarize, in this case, one of the values, or one of the coordinates rather, would be minus 8 for x and 16 for y. And the other one will be minus 8 for x and plus 8 for y. So these should be the coordinates in this case of the 2 points concerned. So that completes part A of this problem. Now let's move on to part B. So part B, find the gradient of the curve at each of these points. So let me try part B here. So for part B, let me copy down the curve equation. So it's x cubed minus 4y squared, and that is equal to 12xy. Now we need the gradient, and in order to work out the gradient we need to calculate the gradient function dy over dx. So whenever you need a gradient, think of the gradient function. So we need dy over dx, and in order to work out the gradient function dy over dx for this equation is an implicit function, so we need to use our knowledge of implicit differentiation to calculate dy over dx first, and then we can work out the gradient at each of these points found in part A, and the points had coordinates, remember, -8, 16 and -8, 8. But first things first, let's use implicit differentiation to differentiate this equation. So if you're unaware, in order to differentiate implicitly, I have created videos in the past and I'll provide links to these videos in the description below. But let me talk to you about the steps. So let me talk through the steps. The first step, let me call that S1, is to differentiate each term with respect to x. So you need d by dx of the first term, x cubed, minus, so a minus. You need d by dx of the second term, which is 4y squared, and that is equal to, you also need d by dx of the right hand term, 12xy. So in other words, you need to differentiate each of these terms with respect to x. Now d by dx of x cubed, we know when you differentiate x cubed you're going to get 3x squared. So for this term we know that the answer is 3x squared. We can do that immediately. Okay. However, let's calculate these two, d by dx of 4y squared, let me call that number 1, and d by dx of 12xy, let's call that number 2. Let's do these as side calculations. So if I go back to blue, let me do a side calculation of number 1 firstly. So we need d by dx of 4y squared. So again, if you're unaware of implicit differentiation, I'll provide links to the videos explaining the method along with examples in the description below. But if you want to differentiate a y term only, so you got 4y squared, a term involving y only, we need to use the chain rule. So the chain rule is we first differentiate with respect to y, so we need a d by dy of 4y squared, then we multiply by dy over dx. So we use the chain rule to differentiate a y term only. So 4y squared is a y term only, it's in terms of y only. When I differentiate 4y squared with respect to y, we're going to get 8y, multiplied by dy over dx, so I'll leave it as 8y dy over dx. So that is the completion of number 1. But let's talk about number 2. So another side calculation for number 2. So number 2, we need to differentiate, and let's recall, so it's 12xy. So let me copy this down, so 12xy. Now to differentiate a term involving x and y, we need to use the product rule, as y is a function of x. So in this case, I normally say that whenever you differentiate a term involving x and y, it's the product rule. If it's of a fraction form, you could use the quotient rule, but in this case you've got two terms multiplied, so it's going to be the product rule. However, going back to point number 1, just to reiterate, whenever you differentiate a y term only, it's going to be the chain rule. So if I still use the blue pen, so with the product rule, I'm going to take my u to be 12x, and I'm going to take my v to be y. So let me write down the product rule here. So by product rule. So remember the product rule, so let me elongate this curly bracket. So d by dx of uv. So that would be v du over dx plus u dv over dx. So that is the product rule that I'm referring to. Now, I've chosen that to be the first term, 12x, and with the product rule we need du over dx. So du over dx, when I differentiate 12x, simply 12. So that is du over dx, so we certainly need that. V on the other hand is y, so v, I've chosen that to be the remaining term y. Now going back to point number 1 earlier, I do have a y term only, so that means that we need to use the chain rule to differentiate with respect to x. So that is dv over dx. Remember the chain rule, differentiates the y term with respect to y, then multiply by dy over dx. So if I go one stage further, d by dy of y, that's simply 1. So if I continue below, so dv over dx, so dv over dx, that is equal to 1 into dy over dx is dy by dx. So that's the side calculation for dv over dx. So let me put a bracket, complete the bracket rather, over here. So this is all side calculation for number 2. Now let's replace the data in our product rule. So on the left we have d by dx of uv. U is 12x and v is y, so 12xy. That is equal to v, which is y, so let's replace by y, times du over dx, which is 12, so times 12, plus, and u is 12x, so let's replace by 12x, times dv over dx, which is dy over dx. So this is what we'll get as a result of the replacement into our product rule. Let's continue. 12 times y is 12y, plus 12x times dy over dx. Let me leave it as 12x dy over dx. So that it should be the answer to number 2, and we have the answer to number 1. Let's incorporate that in the main calculation step here. D by dx of x cubed, we said 3x squared. So if I scroll below, so we've got 3x squared minus, and for number 1, so number 1 we had this. Now what I would suggest is when you do your replacement, just be careful. I would encourage you to use a bracket. So minus, and for number 1 we had 8y dy over dx. So let me copy it out here. So 8y dy over dx, close bracket. Now on the right, d by dx of 12xy, we call that number 2, and for number 2 we had all of this. So that is equal to another bracket, 12y plus 12x dy over dx, close brackets. So that is what we have upon replacement into our equation. And let's rearrange. So remember the plan, we need dy over dx first. So let me take this dy over dx term to the right, but at the same time moving this 12y to the left. So according to my rearrangement, if I take this to the right, so we have the 12x dy over dx term. So let me copy that down. Minus this dy over dx term moved to the right would make it a plus. So a plus 8y dy over dx. And that is equal to, I have the 3x squared term, but taking the 12y to the other side would make it a minus 12y. Now we need dy over dx, so in my next step I'm going to take a common factor of dy over dx. So I'm going to factorize, giving me a 12x plus 8y within the bracket. That is equal to the 3x squared minus the 12y on the other side. So let me go one stage further. So let's rearrange for dy over dx now. Dy over dx will be 3x squared minus 12y, all divided by the 12x plus 8y. So 12x plus 8y. So that is dy over dx, but we're far from done, because according to the question we need the gradient at each of these points, and the points refer to the points from the first part. So let's work out the gradient at this point, minus 816 first. So let me continue here. So at minus 816. So let's replace the data in dy over dx. So I'm going to say gradient. And let me call this gradient m1, say, for the first gradient. M1's equal to 3 into x replaced by minus 8, so it's a minus 8 squared, minus the 12, y replaced by 16, divided by, and below we have 12 into x replaced by minus 8, plus the 8, so plus the 8, y replaced by 16, close bracket. Now let's calculate that. So this is where our calculators kick in. So 3 into minus 8 squared, and we have a minus 12 into a 16, close bracket. So we have a 0 on top. So 0 over anything is 0, so 0 being the first gradient. And for the next one we have minus 8, 8. So let's do the same for the next point. So at minus 8, 8, let's work out the gradient. So gradient, and let's call that m2. So m2 meaning the second gradient. So m2 is going to be, so doing the replacement, 3 into minus 8 squared minus the 12 into, and the y in this case is 8, so 8, all divided by, and below we got 12 into x, which is minus 8, plus 8 into, so plus 8 into y, and y is plus 8. So let's use our calculators. So 12 into minus 8 squared minus 12 into plus 8. So on top we got 96. So 96, all divided by 12 into minus 8 plus 8 into 8. So we got minus 32 on the bottom. So minus 32 on the bottom. And 96 over 32 is 3, but don't forget the minus, so minus 3. So here are the two gradients corresponding to these 2 points. So that completes this question, and that sadly ends the video. So I hope you enjoyed the video. If you did enjoy the video, be sure to like and subscribe, and I hope to see you again. Thank you.